Today, we will look at application problems. When it comes to application problems, also known as word problems, we tend to get scared. A bunch of reasons why. I think the main reason is because, in general, we know we tend to be afraid of math, and now we're seeing math in words. And we have to translate those words into equations before we can solve the application problem. Many times, word problems involve more than one unknowns. Each unknown should be represented by a variable. After this is complete, we must write the relationship between the variable and that of the equation. For example, if we have two unknown, then we will have two equations, and this will form a system of equation. Here are some steps to follow as you try to solve application problems. 1. Read the problem and then mentally list items that are unknowns. Do not try to write or solve a problem by reading it once. Sometimes you may have to read a problem 3 or 4 times. 2. Assign variables to each of the unknown items. That is, let X represent one of the unknown, let Y represents the other unknown, and so on. Reread the problem and now try to write equations using the information you wrote. Upon obtaining the equation or equations, you will now solve the equation. After solving, check your work and write the answer representing or using sentences. We'll now look at some examples and see how we can apply what we have just learned. So our first example, one number is 2 more than 3 times another. Their sum is 26. Find the two numbers. Let's read that again. One number is 2 more than 3 times another. Their sum is 26. Find the two numbers. Now you can take a brief moment and read this as many times as you want. Keep in mind, after you read it about 3 times, you may start wanting to write things down. Sometimes read it out aloud. This may help. I recall once what I did as a student. I read it and recorded it on my cell phone, then played it back and I listened to what I said. So you will have to come up with some way where you will understand or try to gather the information as you read the problem. We do know we have to work with two numbers. So some hints here is hints / notes is that we have two numbers, okay? One, we have two numbers. Okay. We also know the sum of the two numbers is 26. We also know that one of the number is 2 more than 3 times 2 more than 3 times the other. Okay? So keep in mind we have 2 unknowns. And how do we know we have 2 unknowns? Because we have 2 numbers. Okay? So what we can do here, we can let x represent, okay, one of the numbers, let y represent the other number, or the second number. Okay? And then what we can do is try to write equations. So here we go. Okay? It says that the sum of two numbers is 26. So from reading, x plus y is equal to 26. Okay? Because this says the sum of two numbers is 26. Okay? From the first sentence, okay, it states that one number, so we don't know what that number is. We could call it x, we could call it y. So y is equal to a number, one number, is 2 more than 3 times another number. So it's 2 more, meaning plus 2, than 3 times the other number. So if one of the number was x and one was y, and you're saying y is equal, then that has to be 3 times x. Okay? Or you could have written x equal 3y plus 2. It doesn't matter. Okay? That doesn't matter. But what we do know is one of the number is 2 more than 3 times the other number. So our two equations are x plus y equals 26 and y is equal to 3x plus 2. So right now Okay, we have a system of equation. Here is our system. Yeah. And we have learned how to solve system of equations. We have looked at the addition method or the elimination method, and we have looked at the substitution method. And because one of the variable here is already solved for or isolated, I think it is best to use the substitution method. So now let's solve. Let's solve. Okay? Using the substitution method. So we have x plus y is equal to 26. We know y is equal to 3x plus 2. So y is 3x plus 2. So what we do is take the first equation, okay, or let's label them equation 1. Let's call this equation 2. So take equation 1 and replace y with 3x plus 2. And if we do that, we have x plus, instead of y, we'll have 3x plus 2 equals 26. Okay. Now we simplify and solve. So by removing the parentheses, there's no number on the outside here to distribute. So we have x plus 3x plus 2 is equal to 26. Combining like terms, these are like terms, we have 4x plus 2 is equal to 26. We're solving for x, so we try to isolate the x. So we'll minus 2 first. And that leaves you with 4x is equal to 24. And then we divide both sides by 4 to leave x by itself. So x is equal to 6. Okay. Now remember, we have two numbers, right? You have to remember, okay, this is only one of the variables you have. We know x plus y is equal to 26. So if x is equal to 6, we use equation 1, use equation 1 or equation 2, okay, to find y. So we have x plus y is equal to 26. So we're going to replace x with 6. So 6 plus y is equal to 26. Okay. 6 plus y is equal to 26. We'll minus 6 on both sides. So this cancels or becomes 0. So y is equal to 20. Yeah. So that's our value of y, okay? So finally, the note here, okay? The note, okay? The two numbers are 6 and 20, okay? Now you can check, remember to check, okay? The sum, okay? The sum of the two numbers, sum of the two numbers is 26, okay? And 20, because we had said y in our second equation. If you look back at the second equation, we had said y here, okay? Y is equal to 3x plus 2. So we said the value of y is 20. So 20 is 2 more than 3 times 6. Because 3 times 6 is 18. 2 more mean plus 2. So 18 plus 2 is 20. So our answers have checked. So let's look at a second example here. Okay. Example. A common example here is what we call the ticket problem. Okay. Ticket problem. So suppose 850 tickets were sold for a game. This can even be the movie. Okay. For a total of $1,100. Okay. So 850 tickets were sold for a game for a total of $1,100. Now, if adult tickets, adult tickets cost 150 and children ticket okay, cost $1. How many of each kind of tickets were sold? Okay, so let's read that again. Suppose, okay, 850 tickets were sold for a game, okay, for a total of $1,100. if adult tickets cost $1.50 and children ticket cost $1, how many of each kind of tickets were sold? So try to read this maybe one, maybe two, maybe three, sometimes four more times. And as you start to read it more than 2 or 3 times, you can probably start to make notes. Okay? Give that a minute and let's see how it works. So we're saying that the total number of tickets is 850. Okay? So total tickets, okay? Total number of tickets. So hint, total number of tickets sold is 850 tickets. Okay. Now the money, total income from tickets or from selling tickets is $1,100. It's $1,100. We also know that adult tickets cost $150. We also know that children tickets cost $1. Okay? We do not know how many of each types of tickets are sold. Okay? So what we can do now is assign letters. We can say, we can let, okay, A represent adult tickets, and let C represent the number of child tickets. So we can put here also represent the number of adult tickets. So what do we have for equations? Okay. Now we don't know how many of each type of tickets were sold, but we know that the number of adult tickets, which is A, plus the number of children tickets, that was equal to 850 tickets. Okay? Right? The number of tickets sold X or A plus Y or C is equal to 850. So you didn't have to use A and C. You could have used X and Y if you choose to. Just make sure you know what variable you're using, because at the end of the problem, you will have to save. Okay? Now, because each adult ticket costs $150 and children ticket costs $1, the total of money paid for tickets was $1,100. Okay. So now if we look at the money, right, from the money part, money, we have adult tickets cost $150 and child tickets cost $1. So we don't know how many adult tickets we sold. So this becomes 1.50 times the amount of adult tickets plus 1.00 number of times the number of children tickets, which we call C. That brought in a total of $1,100. Okay? That brought in a total of $1,100. So we have two equations. We now have two equations. My two equations are as follows. A plus C is equal to 850 and 1.50A plus 1.00C is equal to $1,100. Now obviously we don't want to work with decimals here, okay? So I would get rid of the decimal, okay? You have, these are decimal numbers, actually. These are decimal numbers, so let's get rid of them. Move the decimal 2 places to the right. If we do that, we have 1.5 plus 1.00C is equal to 1100, and there's a point there. Okay. So if you move it 2 places, and you don't have to move 2 because this 0 doesn't have values. So you can just move it 1. Okay. So this here, you could just move it 1. So this becomes 1 place value, another, and here you have 1. So if you move it 1, this becomes 15A plus 10C is equal to now 11,000. If you wanted to move it 2, you'll have 150A, 100C, and 110,000. Just that the numbers are bigger. So now let's solve. Okay, let's solve. Two equations. A plus C is equal to 850, and 15A plus 10C is equal to 11,000. We can use the elimination method. Let's call this equation 1, equation 2. So we can multiply equation 1 by -10 and multiply the second equation just by 1, as we discussed when we did solving equation. So right now, multiply this equation here by 10, but one of them has to be a negative, so -10. So if we do that, we have -10A minus 10C is equal to minus 8500. The second equation we can just multiply by 1 because we're not changing anything. So 15a plus 10c is equal to 11,000. Remember we said we're using the elimination method. So if you add these, you always add. This becomes 5a. This eliminates 0. And minus 8,500 plus 11,000 becomes 2,500. We'll divide both sides by 5. So we have A is equal to 500. Okay? But we've only solved for A. So to find C, we use equation 1, which is A plus C is equal to 850. A is 500 plus C is equal to 850. If we minus 500 on both sides, we have C is equal to 350. So what does this tell us now? Right? If we translate the answer, the number of children tickets is 350 and the number of adult tickets is 500. So obviously here, okay, there were more children than adults. And you should also, on your own, check your work. Check your work. You must check your work. So as a little assignment for you, you can check your work and see if this makes sense. So our next problem is what I call a business problem. Okay. And we're looking at bank account with investments. So here we go. Suppose a problem invested, or a person, sorry, invested a total of $10,000 in two accounts. So you have $10,000 and you put it in account. Generally, if you go to the bank, there's a saving account and a checking account. So that's sort of the deal. One account earns 8% annually. We know that's not happening, 8%. And the other earns 9% annually. So let's say generally saving pays more than checking. So one account could be the checking account, the other could be a saving account. And the total interest earned from both accounts in a year was $860. So we want to find out how much money did you really put in each account to get that interest. Okay. So we'll look at our hints and notes now. Okay. You may want to read this a few more times. Okay. Read this a few more times and get some information. So take a few minutes and read. Okay. After reading, you will notice that the total investment is $10,000. Okay, you will notice that we have two accounts. This is split between two accounts. Okay, one account earns 8% or 0.08. Okay, the other account earns 9% or 0.09. Okay. We know that the total interest, the interest from both accounts is $860 in 1 year. So what do we want to do? We know we have two accounts. So let X represents the account that invests at 9%, and let Y represent the account that invests at 8%. So now we can come up with equations. Okay, equations. We know that one account plus the other account, we invested $10,000. Okay. So in both accounts, they were $10,000. We also know that the interest earned. Okay. So you have to remember here that X represents the account at 9% and Y represents the account at 8%. Okay. You have to be very careful, don't mix them up. So we have 9% or 0.09x plus 0.08y, and that is equal to the money we earned in interest, which is $860. Okay. So this is interest, this is interest, this is the interest money. So the second equation has to do with all interest. Okay. And once again, we're going to get rid of those decimals. So move 2 decimal places. So if we move 2 decimal places, 1, 2, 1, 2, here's the decimal, 1, 2. So this becomes 9x plus 8y is equal to 860, and we move it 2. Moving 2 decimals is the same as multiplying by 100. So 2 equations are, okay, x plus y is equal to 10,000. And our second equation that we just obtained is 9x plus 8y, and that is equal to 86,000. Now you can solve for x and y. Okay? So let's use the elimination method. So let's call this equation 1. Let's call this equation 2. So we'll multiply equation 1 by, we can do minus 8, or you could do minus 9 if you want to get rid of the x. So by doing this, we have minus 8x minus 8y is equal to minus 80,000. We've multiplied the bottom equation by 1, so that's become 9x plus 8y is equal to 86,000. If you add them, you get x is equal to 6,000. Okay? Now remember, use equation 1 to find y. X plus y we know is 10,000. So x is 6,000 plus y is equal to 10,000. We can minus 6,000 on both sides. So we have y is equal to 4,000. Now you cannot say x is 6,000 and y is 4,000 because we don't know what x and y is. So what we do know, okay, the amount of money invested at 9%, right? Go back and look at VC. If you look up here, right, X was at the 9%. So what value did you obtain for X? You obtain X to be 6,000. Okay? X is 6,000. So the amount of money invested at 9% is $6,000. Okay? And the amount of money invested at 8% is $4,000. You guys can do a check, right? 9% times 6,000. Okay, that will give you 540. And 8% times 4,000 is 320. So the total interest earned in the two account is 860. So make sure to check. How do you check? Just briefly, 9% of 6,000 and 8% of 4,000. Or you can write 0.09 times 6,000, 0.08 times 4,000. And this here, 0.09 times 6,000, that is equal to 540. 0.08 times 4,000, this is equal to 320. So you did get an interest of $860. Okay. So these are some common application problems when dealing with system of equation. So what I'm going to do is assign some problems for you to try now. Okay. I would like you to log into your homework system, try the problems. There is no quiz this week, just homework problems. So please try your work, go over the notes, look at the videos. You may need to revisit this video to actually go over the work, because like I said, application problems can be very tedious. Okay. And hopefully you guys will be able to answer your homework. Bye.